In this lesson, we're going to examine one last application of trigonometry. We're going to look at something we call bearings. And bearings are really an application that involves geography. They relate to compasses. So there's two different ways we can actually measure bearings. One of them deals with our cardinal directions. So cardinal directions are the northeast, southwest idea. So here's my compass. You see this diagram here, northeast, south, and west. When I talk about bearings in terms of my cardinal directions, I need to know where to start, so my starting position, and then in which direction does it go. So N30 west means I start north and go 30 towards the west. In other words, this angle is 30. Now the nice thing about cardinal directions is that they're always 90 degrees apart. So east and south would be 90, north and east would be 90, and again, this is 90. So once I know that one side is 30, I actually know the other side has to be 60. Okay? So for another example, let's say I had S10W, would mean I'd start south, which is right here, and I'd go 10 degrees towards the west. So I know this is 10, and the other angle would have to be 80. Okay, so that's one way of measuring a bearing, cardinal directions. The second way, a standard bearing way, measures from north. When we go from north, we always go clockwise. So again, because we're 90 degrees apart, I know this is 90, 180, 270, and then back to 360 again. So if I had a bearing that measured 230, that means it's gone clockwise 230 degrees. In other words, it's gone past 180. How much past 180? Well, 230 minus 180 tells me I've gone 50 degrees past. And again, because we know these are right angles, if that's 50, this has to be 40. You have to add up to 90 degrees. So for another example, let's just try one. If I said I had a bearing of, I don't know, 70 degrees, and that's between 0 and 90, you'd be down here somewhere. I've gone 70, which means this piece here would have to be 20 to add up to the 90. Okay, and we can use these two different ways of measuring bearings interchangeably. So let's take a look at some examples. A sailboat on Lake Huron leaves Southampton and sails 20 degrees west of north for 20 kilometers. So as soon as I see bearings, I need myself a compass. So Southampton has to be our starting point. It's got to be where we're coming from. We want to go 20 degrees west of north. In other words, I want to start at north and go 20 degrees towards the west. That would look like this. I'm doing it for 20 kilometers, and we know this angle in here has to be 20 degrees. At the same time, a fishing boat leaves Southampton and sails 30 degrees west of south. In other words, south 30 west. So from Southampton, which is in the middle, there's Southampton right there, we're going to go this way. We know it's 30 degrees, and we know it went for 15 kilometers. We want to know how far apart are the boats to the nearest kilometer. Here's my x. Now, most bearing questions involving compasses deal with the cosine law. You know the angle between the two things, the things that are moving. But I don't have that angle yet. However, I can calculate that. I know that north and south, these two things, are 180 degrees apart. So if I know one angle is 20 and one angle is 30, the angle in between, the one right there, has to be the 180 minus the 20 minus the 30, or in other words, 130 degrees. That gives me two sides and the angle between them, which is a perfect cosine law question. Okay, so reminders, a squared equals b squared plus c squared minus 2 bc cos a. In this case, a, big A is right here, and little a is the side I want to find. So b squared c squared 2bc, and the angle between them we just figured out was 130. This is what x squared will be. We'll put that all into our calculator at one time. Here we can get ourselves a big number. Okay. I got 31.7. Oh, sorry. 10. I squared it already. Okay, you get yourself a big number, so roughly 1,000 something. Okay, don't forget we want to square root it. comes out to 31.79 kilometers, but it says in the question to the nearest kilometer. So the boats are 32 kilometers apart. And as we've been talking about, I'd like to see the first line, and all I really need to see is the answer. We should be okay with square rooting by this point. All right, let's try the next one. You guys can try this one. Two planes left Toronto, same time. One traveled at 450 kilometers on a course of 260. Oh, I've got bearings. I need a compass. So 450 kilometers on a course of 260. 260 is not quite 270. It's just below that. So it's going to be about there. The other traveled 550 kilometers an hour on a course of 320. 320 is more than 270. It's going to be about there. Remembering Toronto is our starting point. How far apart were the planes after 3 hours? So I need my x. So what are we going to do here? What do we know? Well, we know the first bearing was 260. So from here, this was 260, which means the part in between has to be level 10. We know the other one was 320, which means that this part is, we went past 270 by 50. Oh, I got 50 and 10 together. The angle in the middle has to be 60, which also makes sense because that's the difference between the two bearings. 320 minus 260, also 60. So there's two ways we could get that angle. We know one plane went 450 kilometers an hour. The other one went 550 kilometers an hour. This looks like the last question now, does it not? So let's solve this. What do we got? We got x squared equals 450 squared plus 550 squared minus 2 times 450 times 550 times the cos of the angle between them. All into our calculator, square root it. You guys can do that with your calculators. 507.45 approximately. Okay, but that is kilometers after 1 hour. The question said, how far apart are they after 3 hours? So for 3 hours, I'm going to need to take this answer and multiply it by 3. That's not too challenging, but we can do that. And we should get 1522.33. Now, some people are going to say, well, couldn't you multiply it by 3 right off the bat? And sure, if you times this by 3 and said, okay, we're using 1650, and times this by 3 and said we're using 1350, and then do the cosine law, you'll get the exact same answer. So your choice is multiply by 3 before or multiply by 3 at the end. It doesn't really make a difference. They will both work. The question says to the nearest kilometer. So we'd say the planes are 1522, nearest kilometer, apart after 3 hours. Okay, and those are sort of our two standard basic bearing questions. Let's take one that's slightly more complicated, if you will. Two forest fire towers, A and B, are 20.3 kilometers apart. The bearing from A to B is north 70 east. Oh, I see a compass. Okay, need myself a bearing. Nope, where'd it go? What do we got here? The ranger in each tower observes the fire and radios the fire's bearings from the tower. The bearing from tower A is north 25 east, from tower B, north 15 west. How far is the fire from each tower? So I look at this and I say I got 3 bearings. In fact, I've got bearings from A to B. So the 2 towers aren't beside each other. They actually have a bearing between them. So I'm going to need another compass. Okay, I'm just going to separate this picture here for a second. Get rid of the compass. Okay. Tower A is down here. Here's A. Tower B is north 70 east from there. So Tower B is like this direction. Tower B is right about there. Oops, sorry guys. north 70 east. So I started north and I went 70 to the east to get to Tower B. The fire is north 25 east from A. So my fire is going to be somewhere up here. Tower B, the same fire, north 15 west. So Tower B, I have to go north and then 15 towards the west to get to that tower. There's the fire. Okay, let's put those numbers into our diagram. North 25 east, the first one. It means the distance between these lines, there's 25. Well, if we knew that the red line was 70 and the blue line is 25, I hope you would agree that between them, the difference between them has to be 45 degrees. When I did from Tower B, north 15 west, I knew this was 15. Okay, I can figure the other angle on the inside there again also. This angle here, because I have to up to 90, has to be 75. Okay. We want to know, oh, we also know one more thing. We were told they're 20.3 kilometers apart. We want to know how far is each fire from the tower. So I've got X and Y. I want to figure those out. So here's your big trick for this idea, this lesson. When we come across two compasses like we have in this situation, you can always form a Z pattern. There is a Z pattern involved between compasses because compasses are parallel. I hope you would agree that this line and this line are creating a Z. And the angle that was in here, which was 70, means this has to be 70. And if that's 70, the angle on the inside has to be 20, which means the two angles combined together, the 20 and the 75, makes a total of 95. And if I know that's 95, and I know I had a 45 down here, I can figure out the third angle, that adds up to 180, must be 40. And if I know three angles, I can find my sides, because I can use the sine law. In particular, the sine of 40 is across from the 20.3. And the sine of 95 is across from y. And the sine of 45 is across from x. Okay, so I'm using the sine law to do this question. I'm going to pick two things at a time and cross multiply. Let's do x first. Okay, so I'll pick these two things. Okay, cross multiply. We get x sine 40 equals 20.3 times the sine of 45. I want to get x by itself. So 20.3 sine 45, all divided by sine 40. And that should come out to 22.3. If we do the exact same thing, and totally exactly the same thing, but we're going to use these two this time, same procedure, same cross multiplying, just different numbers, we can get y. So we'll get y times the sine of 40 equals 20.3 times the sine of 95. And we're going to divide out. So 20.3 times sine 95 over sine 40, we get 31.5. And there's your two distances. Okay. Tower A and Tower B. So that's a trickier one. Two compasses, we need to look for Z patterns. Okay, so I'm going to give you guys a chance to try one. So similar idea, we're going to have two compasses in here. See if you can draw the diagram. The diagram's the hard part. So pause the video, try and draw it, and I'll take you through it if you couldn't. So an aircraft takes off from an airport, flies 400 kilometers in direction north 40 east. I see a compass. I need my compass. North 40 east. So start at north, 40 to the east, 400 kilometers. It then changes course and flies in the direction of south 20 east. I need another compass. As soon as I change directions, I need a second compass. My compass has to go on the end of the previous one because that's where my plane now is. So plane's here. It's now going to go south 20 east. So start south, go 20 to the east. There's 20. It's going to do this for 500 kilometers. So my line is a little bit bigger, 500. Okay. Oh, sorry. No, it's not flying 500. I didn't read that right. Let's read that again there. Until it's 500 kilometers from the airport. The airport's where we started. So this is 500 kilometers. Okay. What is the direction of the airport from the aircraft's final position? So our aircraft is sitting right here. I want to know what is the direction of the airport. So how do I get back to the airport if I need to? What direction do I need to fly? It's going to have to be south something east, or east something south. Sorry, west. Wrong direction. This is the west. I need to figure out that angle. What can I do? The first thing I want to do is look for that Z pattern. I know there's a Z in here. Okay, I hope you see the Z goes this direction. There's my two compasses. We know this angle is 40, which makes this angle 40, which makes the combined angle 60 degrees. Okay. I know 60 is across from 500. Those can match up, which means I can find my other angle. I can find the angle in this corner over here. Call this x. Okay, so I can do sine 60 goes with 500. And that's going to match up with sine x going with 400. And we're going to cross multiply. I'm going to leave the 500 on the bottom because it's going to have to go up and then come right back down again. So I'll leave it down there. I'm going to take the inverse of whatever the big mess of numbers comes out to. 400 times sine of 60 divided by 500. And I got 43.85. So hopefully that makes sense so far. Here comes the tricky part though. I need to interpret this. So my bearing, how do I get to the airport? So I need to talk about this angle in terms of my cardinal directions. I think that's the easiest way. I know for sure, now that we figured it out, I'm just going to fix this diagram a little bit, that the angle inside right here is 43.85. I also know, based on Z patterns, and there's another Z right here, right there, that this angle is the same as this angle, is 20. So if this is north, to get to the airport, I actually have to fly, write this down, to the airport. The direction is, okay, here's the tricky part, ready? I gotta start at north and go this far to the west. That way I can end up flying along here. In other words, the 20 and the 43 together. So north, 63.9, west. That's the direction I'm going to have to fly if I want to get back to the airport. So the diagram, in some ways, is a little deceiving. I didn't draw it to scale, so that kind of makes it a little bit tricky. Okay, last part. How far did it fly along the second leg of the journey? So I got a big messy diagram here. Second leg of the journey would be, let's put it in here, we'll call it letter Y. That's my second leg of the journey. Well, I know the angles in my triangle now, right? I've got two of them already labeled, the 60, the 43.85, which means I can figure out the third one. 180 minus will leave me 76.15. Well, that means I can use my sine law now. I know that the sine, for sure, of 60 goes with 500. I know that the sine of 76.15 can go with y. You have other choices. You can use cosine law if you want, because you have two sides and the angle between them. You have different choices of the sine law. There's lots of choices. They all come with the same answer. Okay, I got y sine 60 equals 500 sine 76.15 divided out. And put into our calculator, and you should get 561 kilometers. Okay, now that's a tricky question. There's lots of parts and pieces to that. Try some of the homework, and if you get stuck, come see me. There is a double compass question, and I think number 8 is the tricky one. But try them all if you could.